Something extraordinary happened on July 1st, 2025. A telescope in Chile detected a faint blur of light moving through the constellation Sagittarius. Within hours, astronomers realized they weren't looking at just another comet. They were witnessing something that had traveled across the vast emptiness between stars, carrying secrets from a solar system billions of miles away, hurtling through our cosmic neighborhood at a staggering 130,000 miles per hour. This is the story of Comet 3I Atlas, and what NASA just revealed changes everything we thought we knew about this interstellar visitor. The NASA-funded Atlas Survey telescope in Chile first reported observations showing the object originated from interstellar space. At first, it appeared as nothing more than a moving dot among countless stars. But as astronomers traced its path backward through time and space, they discovered something breathtaking. This object didn't belong to our solar system. Its hyperbolic orbital path indicated it came from outside our solar system. It was only the third interstellar object ever detected passing through our celestial neighborhood, joining the mysterious Oumuamua from 2017 and Comet 2I Borisov from 2019. The discovery sent shockwaves through the astronomical community. Here was a messenger from another star system, potentially older than our own sun, carrying information about distant worlds we may never reach. Within days, NASA mobilized an unprecedented coordinated observation campaign. Every available telescope, satellite, and spacecraft was turned toward this cosmic wanderer. What they found would challenge assumptions and spark debates that continue today. When the Hubble Space Telescope captured its first detailed images in late July, scientists saw something unexpected. Hubble revealed a teardrop-shaped cocoon of dust coming off the comet's solid, icy nucleus. This wasn't the symmetrical glow typically seen around comets. The shape suggested complex processes occurring as the ancient ice began warming under our sun's rays. The comet was waking up after what could have been billions of years drifting through the frozen darkness between stars. But those initial images were just the beginning. As 3I Atlas raced closer to the sun, moving faster than any solar system visitor ever recorded, NASA's fleet of Mars orbiters found themselves in the perfect position for something unprecedented. In early October, the Mars Reconnaissance Orbiter captured what would become one of the closest views any spacecraft would get. On October 2nd, MRO observed 3I Atlas from 19 million miles away, with one of the closest views that any NASA spacecraft or Earth-based telescopes were expected to get. The high-resolution imaging science experiment camera revealed intricate details of the comet's structure that had never been visible before. Meanwhile, another Mars orbiter, MAVEN, was conducting observations that would prove even more remarkable. MAVEN captured ultraviolet images that were unique among all observations in determining the chemical makeup of the comet and how much water vapor was being released as the sun warmed it. What they discovered was astounding. This visitor from another solar system wasn't dramatically different from our own comets, yet it carried subtle signatures of its alien origin. The James Webb Space Telescope, humanity's most powerful space observatory, turned its infrared eyes toward 3I Atlas and uncovered something that gave scientists pause. Observations showed that 3I Atlas is unusually rich in carbon dioxide and contains a small amount of water ice, water vapor, carbon monoxide, and carbonyl sulfide. The chemical fingerprint suggested this comet formed in conditions slightly different from those in our solar system. The ratio of carbon dioxide to water was higher than expected. Scientists began piecing together clues about the alien star system this traveler called home. Even more intriguing were observations from ground-based telescopes. The Very Large Telescope showed that 3I Atlas was emitting cyanide gas and atomic nickel vapor, at concentrations similar to those seen in solar system comets. Here was a profound discovery hidden in chemistry. Despite traveling from an unknown star system, possibly 7 billion years old, this comet shared fundamental similarities with objects born in our own cosmic backyard. It suggested that the processes forming planetary systems might be remarkably consistent across the galaxy. NASA's Parker Solar Probe, the fastest human-made object ever built, was speeding away from the Sun following its 25th close approach when it captured something extraordinary. From October 18th to November 5th, Parker Solar Probe snapped around 10 images of the comet per day with its Whisper instrument. The spacecraft was in a unique position, viewing 3I Atlas from angles impossible to achieve from Earth. The images revealed the comet's tail streaming away from the Sun, a ghostly banner of gas and dust millions of miles long, glowing in the harsh solar wind. But perhaps the most jaw-dropping revelation came from NASA's MAVEN spacecraft. Shannon Curry, MAVEN's principal investigator, stated that the images captured were truly incredible, and the detections they were seeing were significant. The spacecraft had mapped the comet's atmosphere in ultraviolet light, revealing a massive invisible cloud of hydrogen gas surrounding the comet, extending hundreds of thousands of miles into space. This ghost-like halo was only visible to special instruments designed to see beyond what human eyes could detect. As 3I Atlas swept past Mars at just 19 million miles away, even the Perseverance rover, busy exploring ancient lake beds in Jezero crater, paused its work to glimpse the visitor. The rover captured images showing the comet as a faint smudge against a background star field on October 4th. It was a moment of cosmic poetry, a robot designed to search for ancient life on Mars, watching an even more ancient traveler pass by overhead, carrying within it the chemical building blocks of life itself. The coordinated observation campaign involved an astounding array of NASA missions. The Lucy spacecraft, on its way to study Jupiter's Trojan asteroids, captured images from 240 million miles away. The Psyche mission, journeying to a metal-rich asteroid, acquired observations over 8 hours to help refine the comet's trajectory. The Punch mission tracked it for weeks. The Stereo spacecraft watched it brighten unexpectedly. The Soho Solar Observatory caught it when it passed too close to the Sun for other telescopes to safely observe. Even the newly commissioned Vera Rubin Observatory had serendipitously captured images before the official discovery, showing the comet's growth over time. What made this campaign so extraordinary wasn't just the number of observations. It was what those observations revealed about the nature of interstellar space itself. Scientists had long wondered whether objects from other star systems would be fundamentally different from our own. 3I Atlas provided an answer that was both comforting and mysterious. Its chemistry was broadly similar to the solar system's own comets, which was a profound discovery in its own right, though there were differences including a slightly higher carbon dioxide to water ratio and a little more nickel than iron, reflecting the chemical composition of its star system of origin. The age of this visitor boggled the mind. If 3I Atlas originated from the Milky Way's thick disk, the comet could be at least 7 billion years old, older than the solar system. Imagine an object older than Earth, older than the Sun itself, wandering through space for billions of years before finally encountering our planetary neighborhood. What had it witnessed in its journey? What ancient star had it orbited before being cast into the eternal night between suns? Harvard astronomer Avi Loeb, known for his controversial theories about interstellar objects, noted the significance of 3I Atlas making its closest approach to Earth on December 19th. This date coincided with a new moon, when the sky would not be contaminated by moonlight, making it an ideal observing night for Earth-based telescopes. Observatories around the world prepared for this moment, knowing it represented a fleeting opportunity to study a sample from another planetary system. The European Space Agency's JUICE spacecraft, on its way to explore Jupiter's icy moons, also caught the visitor and detected something unexpected. The spacecraft observed surprising amounts of activity as 3I Atlas was heated by the Sun, watching it lose mass as ancient ices turned directly from solid to gas in the vacuum of space. These observations won't be fully downloaded and analyzed until late February, but they promised to reveal even more about this enigmatic traveler. What struck scientists most wasn't just the wealth of data collected, it was what 3I Atlas represented for the future of astronomy and our understanding of the cosmos. Tom Statler, NASA's lead scientist for solar system small bodies, said the possibility that it came from a different planetary system much older than our own gave him goosebumps to think about. Here was tangible evidence that planetary systems form, evolve, and eventually fling their contents into interstellar space, seeding the galaxy with the raw materials of worlds. The images keep coming. Observations are expected to continue for months as 3I Atlas heads back out into the darkness from which it came. Each new dataset reveals additional layers of complexity. Scientists are studying its rotation, its composition, the way it responds to solar heating, and the mysteries still hidden in its ancient ice. Some observations hint at unusual polarization properties in the light reflecting off its coma, suggesting the dust grains might have unique characteristics shaped by their interstellar journey. What NASA has revealed goes beyond simple photographs and spectroscopic data. They've shown us that interstellar space is not an empty void, but a highway for cosmic wanderers. 3I Atlas is likely one of trillions of such objects drifting through the galaxy, occasionally passing through star systems like ours. Most go undetected, invisible against the vast backdrop of space. But with improving technology and dedicated sky surveys, we're beginning to catch glimpses of this hidden population of galactic nomads. The original images captured in July were indeed just the beginning. What followed was a masterclass in coordinated scientific observation, bringing together dozens of telescopes and spacecraft to study a single target during its brief passage through